Welcome back. In this session we're going to look at the core of the X-ray system, the source of the X-rays, the X-ray tube. X-rays are emitted when a high-speed electron hits a metal target. Only 1% of the energy in the electron beam is converted to photons. The rest is converted to heat. So producing heat inside a vacuum is a problem, but it is hard to get rid of it. A large anode can be used to absorb the heat, but this relies on conduction. If the conduction is not rapid enough, the anode will start to melt. So to increase the capacity, the anode is rotated. A new surface is continually exposed to the electron beam. By the time the anode rotates through 360 degrees, that spot of the anode has had a chance to cool down. So let us start by having a look at a real X-ray tube. This is the glass tube, which must contain a high vacuum. Otherwise, the electrons will collide with molecules of air, losing energy. At this end here, we have a hot wire cathode. The thermionic process results in the release of the electrons, which are accelerated towards the anode, which is at between 30 and 100 kilovolts relative to the cathode. When the electron hits the anode, it is decelerated as it collides with electrons in the metal. As it decelerates, it loses energy, which is released as an X-ray. The angle on the anode directs the X-ray beam towards this window. Here we have at this end the motor, which rotates the anode. Let us now go to a diagrammatic depiction of the rotating anode X-ray tube. The cathode is heated to cause the release of electrons. These are accelerated by a high voltage towards the anode, which is positively charged relative to the cathode. This whole process needs to be conducted within a high vacuum. Otherwise, the electrons will strike air molecules and thereby lose their energy before they reach the anode. When the high energy electrons strike the anode, they release energy. Some of the energy is released as X-rays, but most is converted to heat. To prevent the anode from melting, it is continuously rotating, and so the hot spot moves away from the electron beam. It then has time to cool down before it gets back to the position in the beam of the electrons.